Good morning. Today we're going to talk about the laws of exponents. We are on page 29 of your packet. We're going to begin with the product of powers property. What this property simply states is that if the bases are the same, when you're multiplying powers, if the bases are the same, you simply add the exponents. So n to the a power and n to the b power will equal n to the power of a plus b. If the powers are different, you leave them alone. So you put x times y, right? So we show x times y by putting the two variables side by side. The parentheses also shows the operation of multiplication. So it's x times y times times n to the a plus b power. Let's see how this works out. So we have b to the 8 power, right, times b to the 2nd power, right? That is going to be b to the 10th power, because we're simply going to add them up. Why does this work? Because we have b times b times b times b times b. 1, 2, 3, 4, 5, 6, 7, 8. Then we're going to multiply that times b times b. Instead of doing this every time, we simply learn that 8 plus 2 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, y to the 9th times y to the 3rd power will be y to the 12th power. And here, 4 to the 2nd power times 4 to the 2nd power again will be, you guessed it, 4 to the 4th power. Now, because this number is a small number, we're going to be able to simplify that to 256. If the number gets too big, we're just going to leave it in power form. Okay, one thing we have to understand here is that you can multiply these two numbers by each other. So you can multiply 2 times 3, that's going to give you 6, and then we can multiply y to the 3rd times y to the 4th. So we can have 6 times y to the 7th power. Here they have a good concept at work. When you do not have an exponent, there is an invisible 1 there, right? Because 7 to the 1st power equals 7. 8 to the 1st power equals 8. So any number to the 1st power equals that number. And we do not have to write the 1 all the time. So if there is no exponent there, we know that it is a 1. So 7 to the 2nd power times 7 to the 1st power equals 7 to the 3rd power. Moving on, now we're going to move to the quotient of powers property. Alright, this property, right, just like product meant multiplication, quotient means division. Multiplication is the opposite of division. So the opposite of addition is subtraction. So when we are dividing, we're actually going to subtract. Okay, so n to the a power divided by n to the b power equals n to the power of a minus b. Now we're going to do the first one together, and that's going to be b to the 8th power over b to the 3rd power. This is going to equal b to the 5th power, and this is why that works. We have b, 8 times 4, 5, 6, 7, 8 over b. Now before we move any further, if I had 7 over 7, 7 divided by 7, we know that equals 1. If I have 9 over 9, we know that that also equals 1. So if I had 9 over 9 times 5 over 2, I can get rid of these two 9s and I can simply reduce them, and this fraction can still be 5 over 2. That same concept of reducing a fraction is how we subtract the exponents, because b divided by b is 1, and b divided by b is 1 again, and b divided by b is 1 again, and we are left with 5 b's. Okay, so that is going to put up to b to the 5th power. Alright, now we have number 8. We have z to the 5th power divided by z to what power is that? When there is no power, we assume that it's the 1 there, or we know that there's a 1 there. So this is going to be 5 minus 1, and it's going to be z to the 4th power. Now we have coefficients here. We can definitely work with the coefficients. 4 divided by 2 is 2. And we have b to the 9th power divided by b to the 4th power. And we're just going to subtract these powers, so we end up with b to the 5th power. And there's nothing underneath there but a 1, so that equals 2 to the b power. 2 times the b power. 2 times b to the 5th power, I'm sorry. Now we have 12 divided by 12y to the 5th power divided by 6y to the 3rd power. We can work with the coefficients again, leaving us with 2y to the 2nd power. Here we have 15 times x to the 4th power divided by 3x to the 2nd power. And we're going to do 15 divided by 3, we're going to get 5, and x to the 4th power divided by x to the 2nd power, subtract the exponent, x to the 2nd power. Now we have 5 to the 9th power divided by 5 to the 7th power. One thing some students like to do is do this, 1 to the 2nd power. I understand you believe that 5 divided by 5 is 1. That is true, but the bases are the same. So when the bases are the same, we leave the base as is and simply work with the exponents. So this would be 5 squared, which could be simplified to 25. Alright, now we're going to move on to the zero property of exponents. Alright, zero property of exponents simply says that any base to the 0 equals 1. Alright, now this just deals with the negative sign. Remember that the exponent can only see and only affects what's inside of the parentheses. So now it sees the parentheses, so it says negative n to the 0 power equals 1. This one you can kind of break down into n to the 0 power times negative 1. See, that's a negative 1 out there. We can use distributive property to multiply everything inside. So n to the 0 power equals 1, and then we multiply it by negative 1, and by negative 1, and we get negative 1. Now you could do that, or you could simply say that you take the opposite of the answer inside. This 0 here does not see this negative, so that's 1 for the 5 to the power of 0, and we keep that negative. Because this negative is inside of parentheses, the exponent can see the negative sign, so this is negative 17 to the power of 0, which is 1. And this is 2 to the 0 power, right? That's 1. It can't see a negative, so you leave that out in front, plus negative 2 to the power of 0. Now this exponent can see a negative sign because of the parentheses, so that's negative 1 plus 1 equals 0. Alright, let's go to the back of the page, which would be page 30. Now we're moving on to the negative exponents. Here we are with negative exponents. Negative exponents, we cannot simplify negative exponents. We must get rid of the negative exponent first. To get rid of the negative exponent, we have to get rid of this negative sign. The negative sign goes away when you make the reciprocal or the inverse here. Another way to say that is to kick it downstairs, or if it's on the bottom, you kick it upstairs. So one way that some teachers like to explain is that you can't have a teenager with a negative attitude. To get rid of that negative attitude, you send him downstairs if he's upstairs. If he's downstairs, you send him upstairs. Alright, that's just a quick way to remember it. Let's see what we're going to do here. But remember, negative exponents cannot be simplified. They must first be removed. So to remove the negative, it has to go through the division line. You must get the reciprocal or the inverse of what we see. So here we must remember that there's an invisible 1 underneath every whole number. So we're going to take the reciprocal, or we're going to kick it downstairs, so it's going to be 1 over b to the 8th power. Here we have a negative 3rd power, right? Z to the negative 3rd power. To make it positive, we know we can't work with negatives. It's going to be z to the 3rd power over 1. We don't need to write that 1, so it simplifies to z to the 3rd power. Alright, here we have x to the second power divided by y to the negative fourth power. Now there's nothing to do with the x. The x is as simplified as it can go. That y can be changed. So to make that positive is going to be x to the second power times y to the fourth power. Over here, this is a tricky one. They give us two negatives. So they're basically just going to flip-flop, right? Because now we have to get rid of this negative, so it's going to be b to the third power on the bottom. And we have to get rid of this negative 4, so it's going to be c to the fourth power. Here, we have to get rid of the negative, and it's going to be 1 over b to the fifth power times c to the fifth power. And here we have the negative 4, so it's going to be 1 over 3 to the fourth power. Alright, now we have to do the one that can be a little more tricky, power to a power. Alright, if you see here, we are simply using the distributive property. We are going to distribute this power to everything inside of the parentheses. So that's going to be 4. When we distribute, what operation do we use? Yes, we use the multiplication operation. So we're going to use the same thing with power to a power. 4 times 3, 4 times 2. And what number is there when we don't see one? Correct. If a number or variable does not have an exponent, we know that there's an invisible 1 there. So 4 times 1 is going to be 4. Or there you go, 2 to the first power times 4. The exponent here is going to be 2 to the fourth power. Alright, so let's move on and let's see how we're doing. Alright, so here we have 3 to the first power times a to the third power times c to the fourth power. Raise all of that twice. Okay, so we're going to come here. 3 to the first power is 3 squared. And 3 times 2, distribute that over there, is a to the sixth power. And c to the fourth power times 2, distribute it again, is c to the fourth power. Now, there is something we can simplify here, and that's 3 squared. 3 squared we can write as 9. And that would be your final answer. Alright, and this does make sense if you play it out. It goes 3 a to the third power, c to the fourth power times 3 a to the third power times c to the fourth power, and we would just go ahead and work with like terms. So we could do 3 times 3, that would be 9. A to the third power times a to the third power. Remember, when we multiply, we add, so that'd be a to the sixth power. And when we multiply again, it will be c to the did I do that right? That should be 8. Should be 8. See, even Mr. McGee makes mistakes. C to the 8th power when we add it in there. So that's a good reason why we always go back and check our work. You always want to get those questions right. Let's see here, when we don't have an exponent, we have a 1. So 6 times 1 is 6. I can do that. And we do have an exponent. 6 times 5 is 30. Y to the 30th power. And here we're going to go to the top and the bottom of that fraction. So it's going to be 2 to the third power over 3 to the third power. And we can reduce this to 8 over 27. And we do not want to use decimals. We want to leave them as fractions as best we can. Alright, so that in a nutshell is the laws, or are the laws of exponents. I hope you enjoy the music playing as you guys go through the hallway. Alright, have a good one.